we have learned what a complex number is. We've talked about adding, subtracting, multiplying, and dividing complex numbers. And now we're going to talk about graphing them. Complex numbers, as we have learned, take the form of a plus bi, where a is the real part of the number and bi is the imaginary part. We can plot complex numbers on the complex plane, where the x-axis is the real part and the y-axis is the imaginary part. Essentially, we're thinking about a coordinate plane very similar to what we've talked about before. However, now instead of this being the x-axis and the y-axis, it's the real axis and the imaginary axis. And so we just go ahead and we would essentially plot this like an ordered pair, where the real part is 2, or the x value is 2, and the imaginary part, or we could consider it like the y value, would be 5. So in order to plot this first one, 2 plus 5i, I would go over 2 in the real and then up to 5 in the imaginary part, and I would plot that point, that is 2 plus 5i. And we could also plot 6 minus I. We would go 6 in the real direction and then negative 1 in the imaginary direction. So this point here would be 6 minus I. If we are given just a real part or just an imaginary part, for example, plotting 4, that's a real number. Therefore, the imaginary part is 0. That's akin to having 4 plus 0i. That's the exact same thing. And so that would just be on the axis, on the real axis, that it would be a location for 4. And 7i, we would have the same thing. This is 0, like 0 plus 7i. So it would be on the imaginary axis at positive 7. And then negative numbers work in the same way that we have seen all of our other items here. And so if we wanted to plot negative 5 minus 3i, we would go negative 5 in the real direction, negative 3 in the imaginary direction, and plot that point. So plotting complex numbers is relatively simple and straightforward. Now, in part 2 here, it says, on the real number line, the distance from 0 to a point on that line is defined as the absolute value of a number. And so think about it. If we have a number line with 0 in the middle, the distance from 0 to 4, or the absolute value of 4, is 4. The distance from 0 to negative 4, or the absolute value of negative 4, is 4, because distance is always positive. Similarly to this, in the complex plane, the absolute value of a complex number is its distance from 0 or its distance from the origin. Find each of the following by sketching the complex number in the complex plane will help to visualize the results. So I'm going to draw a sketch here of negative 8 plus 6i. We would go negative 8 in the x direction, or in the real, on the real axis, and then positive 6 in the imaginary direction. And therefore, this point would be up here at negative 8, 6. Now, absolute value is, as we talked about, is distance away from 0, or the distance away from the origin. So the absolute value is this distance. That is our absolute value. And so we need to figure out what that distance is. And we can figure out what that distance is by using a nice little right triangle in here, where we know that this side of our right triangle is -8, and this side of our triangle is 6. So the absolute value of -8 plus 6i is going to be -8 squared plus 6 squared is equal to whatever that absolute value is. So we're going to say maybe c squared. 8 squared is 64 plus 36 is equal to c squared. Or let's actually make that a d because distance. And 100 is equal to d squared. Therefore, d is equal to 10. And so the absolute value of -8 plus 6i would be 10. So we could say, I'm going to put it down here, our answer for part A. The absolute value of -8 plus 6i is equal to 10. We could do the same thing for any other complex number. So this one, 4 plus I. So that would be here at 4, 1. We have a height of 1, a distance here of 4. And so our distance for B is going to be 4 squared plus 1 squared is equal to d squared, or 16 plus 1 equals d squared. And so our distance ends up being the square root of 17, or the absolute value of 4 plus I is equal to the square root of 17. If we wanted to find the absolute value of A plus BI, we no longer have any numbers, we just have variables. And notice we take the square root of the sum of those two things. So our distance squared is equal to A squared plus B squared. And to solve for that d, we take the square root on both sides. So our absolute value of A plus BI is always going to be equal to the square root of A squared plus B squared.